So question 97, can we make it to 100 not out? Let's have a look how you got on with this one. So here we are. The question's asking us to find the turning points, or at least the x coordinates of the turning points. So I'm immediately thinking about differentiating and making dy dx equal to 0. I'm just also looking at this word here, exact, which is important. We'll make sure that we incorporate that into our solution. So if dy dx is this, then, if y equals that, then dy dx is this. Now, when I tried to solve that with my calculator using the equation solver, I got x equals 2, but also 2 decimal numbers, which are clearly not exact. So I'm going to have to do a little bit more work on this one. Now, the fact that x is 2 is a solution means that x minus 2 is a factor. And that's confirmed here using the factor theorem. So I can express dy dx as this factor multiplied by a quadratic factor. So the quadratic factor I'm calling ax squared plus bx plus c just for the moment. So I need to find out what a, b and c are. I've multiplied the brackets out there, and you can see that I've got a coefficient of x cubed, a coefficient of x squared, a coefficient of x, and then an independent term at the end there. And I can compare those with the coefficients of dy dx here, the coefficient of x squared being 0. So comparing the coefficients of x cubed, I immediately get that a equals 4. Then comparing the coefficients of x squared, 0, x squared in dy dx must equal this minus 2a plus b here. So using the value of a, which I've already got, I can find that b equals 8. And then comparing the coefficients of x, I get minus 38, which is this here, is the same as c minus 2b, the coefficient of x there. So I would find a figure of c of minus 22. And I always like to look at the independent terms as well. The independent term plus 44 equals minus 2c. So that means that c equals minus 22. So we're getting the same answer, and that gives me a nice warm feeling that I haven't made any mistakes anywhere. So that means that dy dx can be expressed as this linear factor multiplied by the quadratic factor. So I'm still trying to find the x coordinates of the turning points, which means I'm trying to find where dy dx equals 0. So this tells me immediately that x equals 2 is one of the solutions, but I need to find the other two solutions by solving 4x squared plus 8x minus 22 equals 0. And I've used the quadratic formula here to get the two answers in addition to the 2. So those are the three x coordinates of the turning points. So we've answered the first part of the question. We've now got to classify the turning points, which means deciding whether they are maximum or minimum turning points. The easiest way, I think, to do that is to look at the sign of the second differential. So if I take my expression for dy dx and differentiate a second time, then I get d2y dx squared is that. And when x equals 2, dy dx is a positive number, so that turning point is a local minimum. When x is this value, dy dx is negative, so we've got a local maximum, and the final one is a local minimum. So those are the answers to the question.